In the diagram shown, no friction acts at any contact surface. Initially the spring has no deformation. What will be the maximum deformation in the spring? Consider that all the strings are sufficiently large. Okay, consider the spring constant to be K. If F is the force over here, the same force will act along this point and the same force will pull the mass M in the right hand side direction. Now if F is the force over here, 2F force will act along this direction and the same 2F force will pull the 2M mass in the left hand side direction. Okay. Now let us say that the total force on the small m mass, let it be equal to F over here, and it gets extended by a distance x1. Okay, it gets extended by a distance x1. So similarly for 2m mass, let the extension produced be equal to x2. Okay, we will use this later, but let the extension produced be equal to x1 and let the extension be produced be equal to x2. Okay, now I can clearly say that if the total extension in the spring is x, it will be equal to x1 plus x2. Okay, it will be equal to x1 plus x2. Let us start solving this part. Okay, first of all, the work done will be equal to change in the potential energy of the spring. Okay, the work done will be equal to the change in potential energy of the spring. Okay, the work done over here will be equal to force into displacement of the first one, which is equal to F into x1 plus force into displacement of x2. Okay, the force on the second case is 2F2. Okay, 2F into x2 will be equal to potential energy of the spring, which is equal to half kx square. Let this be the first equation. Okay, let this be the first equation. I want to calculate x1 and I have to convert x1 and x2 in terms of x. Now understand that over here, if I consider the center of mass of the two bodies, okay, if I consider the center of the mass of the two bodies, okay, I can clearly say that, okay, if I consider the center of the mass of the two bodies, I can clearly say that m into x1 will be equal to 2m into x2. Okay, m into x1, that is m into the displacement of x1, will be equal to 2 into m into x2. Okay, because over here if you consider this part, both of them are connected by spring. Okay, both of them are connected by spring. Okay, it means that if I consider the center of mass at whatever distance it may be, okay, it will remain constant. Okay, so I can say that x1 will be equal to 2 times x2. Okay, x1 will be equal to 2 times x2. Okay, let this be the second equation. So let us convert everything in terms of x. Okay, when I substitute 2 times x2 plus x2 will be equal to x. So I can say that x2 will be equal to x divided by 3. Okay, x2 is equal to x divided by 3. So x1 will come out to be 2x divided by 3 when I substitute in the same equation. Okay, when I substitute in the same equation, it will come out to be 2x by 3. Let us substitute the values in the first equation. F into x1, so f into 2x by 3 plus 2f into x2. x2 will be equal to x by 3. It will be equal to half k x square. Okay, it will be equal to half k x square. So it will come out to be 2fx divided by 3 plus 2fx divided by 3. 4fx divided by 3 will be equal to half k x square. So basically x square and x will get cancelled out over here. K will be equal to 8f divided by 3k. Okay, the over here the k will be equal to, the x will be equal to, over here the x will be equal to 8f divided by 3k. This will be the extension produced in the string.